With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello everyone, let's start the question. Question says the diagram shows that a small bit of mass m carrying a charge q. The bit can freely move on the smooth fixed string placed on a smooth horizontal plane as shown. In a same plane, a charge positive q has also been fixed as shown. This is charge plus q. The potential at point P due to the positive plus q charge is capital V. The velocity with which the bit should be projected from the point P so that it can complete a circle should be greater than. Basically, we have to project a bit from this point P, and that bit should complete this circle, right? And according to the question, the potential given by this charge plus q is V at this point P, and which is equals to kq by 4a, right? Because the potential is equals to kq by r, and r in this case is the distance between charge q and point P is 4a. Now the potential at this point, which is this point B, point A, at this point the potential is kq by a, right? Or we can write the VA is 4 times of V, right? Now, when we project this bit with velocity let V, right? Then, due to this charge plus Q, the electric field is around the on the surface of this ring, right? And let the electric field at this point be in this direction, away, radially away from the charge q, right? And the component of this electric field E is 1 in this direction and 1 in this direction, right? Now this component, which is in positive x direction, is oppose the velocity of the bit, right? And at this point also, the electric field in this direction and the component is in this direction. So it opposes the speed of the bit, or you can say the velocity. Now, what's the velocity? What's the electric field at this point? This point is point C. So the electric field again in this direction, and one component is in this direction and other one is in this direction. So this component of electric field again opposes the velocity of the bit. Now what happened at this point? Let this point be point D. In this point, the electric field is in this direction, away from the, radially away, and the one component of electric field is this one, and the one component is in. Now in the lower half of the circle or a ring, we can see that the electric field component support the velocity, right? Or the force due to this electric field support the velocity component, right? So we have to choose that minimum value of the velocity of a bit which take the bit at this point, right, at point A. So we can say that at point A, the velocity of the bit should be 0, so that after point A, it move with the help of the electric field component and due to the force of this electric field, right, and move, cover this half part, right? Now at point A, we have velocity is equals to 0. Now from conservation of energy, throughout this process is conserved. So we can see that potential energy due to this charge Q is we can write that V, the potential due to this plus Q charge, into Q, the potential energy, plus the kinetic energy of this bed, which is half m V minimum. We need that minimum velocity equals to the final kinetic energy and the potential energy. So the final potential energy is at this point. We have to choose that minimum velocity which projected from this point, point P, and reach to the point A. And after point A, it moves with the help of the force by the electric field, right? So at this point, the final potential energy is 4, potential is 4V. So we can, the potential energy is 4V into Q, plus the kinetic energy is, at this point the velocity is 0, right? So kinetic energy is half m 0 square, right? So from this we can write that V capital small q plus half mv minimum square is equals to 4v q, right? Or we can write it as half mv minimum square is equals to 3 capital V Q, right? Or we can write mv minimum square is equals to 6 capital Q, right? So V minimum is, we can write velocity minimum required to project this bit is 6v q m by m, sorry, right? Or V minimum is under root of 6v q by m. This is the required velocity to project this bit from this point P. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.